Okay, it says, number 6 says use the rational zero theorem to list the possible zeros. So we need the factors of this, of 3, which is plus or minus 1 and plus or minus 3, and the factors of 18. That's plus or minus 1 times 18, 2 times 9, 3 times 6, and that's it. And then we said 9 and 18. So now what we have to do is do the factors of 18 divided by the factors of 3. So we're going to get these factors right here right away. And then we're going to have to, so that gets us those ones there if we divide by 1 or negative 1. And then we're going to go, now we're going to have to take all those numbers and divide them by 3. So when I do that, 1 divided by 3 is 1/3. And it's plus or minus. 2 divided by 3 is 2/3, and it's plus or minus. I showed you right there, plus or minus. 3 divided by 3 is 1, where I already got it there. 6 divided by 3 is 2, I got it there. 9 divided by 3 is 3, I've already got it there. 18 divided by 3 is 6. So it turns out all the rest of them I've already got in the first list. And I am now done this question. Okay, so I just copied the table from number 7 down. It says, use the location principle to determine the intervals 1 unit in length in which there is a 0. So, remember, zeros happen when it goes from a negative to a positive in the f of x value. So, here it goes negative to positive, so there's a 0 between there. It goes from positive to negative, it's a 0 between there. And then it goes from negative to positive, so there's a 0 between there. And so we're going to write, there's a 0 between negative 4 and negative 3, between negative 2 and negative 1, between 2 and 3. Remember, the real reason is when you draw a function here, when it gets a 0, it has to cross the x-axis. Up here, f of x values are positive, and down here they're negative. And if the function was going the other way, here it's negative, there it's positive. Those are f of x values we're referring to. F of x. Okay, so that's what's happening when you look at the y values. So if you really wanted to write this properly, you would say x is greater than negative 4 and less than negative 3 is the first interval. The second interval would be negative 2 to negative 1. And the last one would be 2 to 3. There would be your intervals there. But I accept it if you just labeled it on the table there. Okay, we've given this function, we have to find the exact values, not decimals, but exact values. And we're going to have to list the possible zeros. Well, here, in the front here, it's only plus, the factor is 1, so plus or minus 1. And the factor here is 20, so it's plus or minus 1 times 20, 2 times 10, 3, doesn't, 4 times 5. We're going to go 10, 20. And when you divide them all by 1, you get this. This is all the possible zeros that are there. So you just have to start trying numbers. You can start trying numbers till you get it. And it turns out that, and if I write the numbers down, 1, 4, negative 5, negative 20. And I just, with gut feeling, tried negative 4 and 4. Okay, so I'm going to put in here negative 4. Okay, now obviously I'm making it quicker, but if you try negative 4, what you get is a 0 there. So this is 0 here. So you get a negative 5, which gives you a positive 20, and you get a 0. So this one works. So x equals negative 4 works. Okay, we got to get a couple more there because we know that this is a power of 3. I need 2 more zeros. So this is 1x squared. This is x. That's a plus sign, and this it's like that. So what we should write it is as x squared minus 5. And we're going to set that equal to 0. So I'm going to add 5 to both sides. I'm going to get x squared equals 5. I'm going to take the square root. Remember, it's plus or minus the square root. Okay? I'm going to get x equals plus or minus root 5. So those are the extra zeros that we need to add with this 0 here, and there's our 3 zeros. Pretty easy, huh? Okay, so we have this function here, and we're supposed to find the exact zeros. Again, this has a 1 in front, so it's plus or minus 1. And I'm going to divide that into every 0 here, which is plus or minus 1 times 16, 2 times 8. 4 does not work, but 4 times 4 is 16. I only have to write it once. And then we had 8 and 16. And again, those are your options. You divide them by 1. I'm going to write it down here, 1, negative 4, 4, negative 16. And we need to do synthetic division as many times as we need to until we find a remainder of 0. So we want this to be a remainder of 0. Okay, well, it turns out you can try lots of things. I see lots of 4s in this. So one of my clues was this has a 4, and 16 is a 4 squared. My gut says try positive or negative 4. Just pick one and see what, and something like that may be a gut check on it. It's not a guarantee, but it was just a feeling I had. So I chose 4. Okay, so I get 1. This is a 4. So that's a 0. And then I get 0 again. So that's a 4, and 4 times 4 is 16. Whoops, I should have wrote 16 there. And I get a remainder of 0. And if I write this out, this is 1x squared plus 0x plus 4. So if I write that, that's x squared plus 4. I'm going to set that equal to 0. Subtract 4. Subtract 4. X squared equals negative 4. I'm going to take the plus or minus square root of that. Saying, well, you can't take the square root of a negative number. Yes, we learned you can do that. So we learned that you can. It's called an imaginary number. You get x equals, well, we'll get plus or minus. And we have the square root of negative 1 times the square root of 4, which is plus or minus 2i. This is I, and that's 2. So there's 2 of our zeros, and we've got all the zeros now. We should have how many zeros? We should have 3 zeros. So when I write this out, the answer is x equals 4 plus or minus 2i, or you can put 2i, comma, minus 2i, whatever you choose to.